Alright, today we're going to answer the question, what are some applications of exponential growth and decay? There are a few formulas that we're going to look at. The first is y equals a times 1 plus r to the t, where a represents the initial amount, r is the growth or the decay rate, so you might have to subtract r, and t is time. The next formula is y equals a times 1 plus r over n to the nt. Notice that the only difference is that we have a divided by n and then another n here. And n represents the number of times compounded per year. And the last one that we'll look at is y equals pe to the rt, where p is the principal or the initial amount. And sometimes instead of this y you see a, which is also just like the ending amount. And we call this continuously compounded interest. Alright, so let's look at this example. A researcher estimates that the initial population of a colony of cells is 250. If the cells reproduce at a rate of 25% per week, what is the expected population in 6 weeks? So if they're reproducing, we have growth. So we're going to add that 25%. So we're using our a times 1 plus r to the t. So our initial amount was 250. 1 plus the rate, and change this to a percentage, so 1 plus 0.25. And we're doing this after 6 weeks. So a little 6 goes up here in the exponent. So after 6 weeks, we could estimate that there would be 953. Now, we have a decimal, but we can't have 0.67 cells. All right, we always have to think about what the context is. If it was money, yeah, we would include the decimals. All right, the next problem. Lance has a bank account that will allow him to invest $1,000 at a 5% interest rate, compounded continuously. That's a great rate. If there are no other deposits or withdrawals, what will his account balance be after 10 years? All right, so we start off with a equals p times e to the rt. So a equals the initial amount, 1,000, times e to the rate, 0.05, since that's a percentage, for 10 years. So this comes out to $1,648.72. So after 10 years, we'd earn a profit of $648 in this account. Now the next part of the problem says, what would the account balance be if the rate was compounded monthly? So I take my compound interest formula and I say, okay, my original was 1,000, 1 plus the interest rate of 0.05, compounded monthly, that means it'll be compounded 12 times a year. And then so this 12 also comes up for 10 years. After 10 years, we see that there's $1,647 and about 1 cent. So slightly less than continuous because it's not compounded as many times in a year, but still a good amount of cash. All right, that's all for today. Goodbye.